Namaste to everyone. I welcome you all in my YouTube video channel. Today I will describe the process to find sample space of random experiments. A coin has two sides. One side is head and other side is tail. If we throw a coin, we get outcomes either head or tail. We know that a sample space is a set containing all outcomes of the random experiment. Here we get outcomes head and tail. Therefore, for throwing a coin, we get sample space S equal to head, tail. These are possible outcomes. If we throw two coins, then possible outcomes be head in the first coin and head in the second coin. Head in the first coin, tail in the second coin. Tail in the first coin, head in the second coin. Tail in the first coin, tail in the second coin. So possible outcomes are HH, HT, TH, TT. HH means the first coin gives the result head and second coin gives result head. HT means first coin gives result head, second coin gives result tail. Result means outcome. In this way we get four outcomes for tossing two coins at the same time. Therefore, for tossing two coins, we get the sample space S equal to a set containing these four outcomes. These are all outcomes. Since sample space is a collection of all outcomes of the random experiment. This sample space will be same if one coin is tossed twice. When one coin is tossed, it gives head or tail. Second time, if it is tossed, it will also give head and tail. So in the first time head, in the second time head, in the first time head, second time tail, in the first time tail, in the second time head, in the first time tail, in the second time tail. So tossing two coins at the same time and tossing one coin twice gives the same sample space. This sample space may be obtained from this sample space as if we take Cartesian product of sample space for a first coin with sample space of second coin, then we get here HH, HT, TH, TT. These are ordered pairs. We may also write these HH, HT, TH, TT. In this way, we get the sample space for tossing two coins be the Cartesian product of sample spaces for one coin. In this way, we may get the sample space for tossing 3 coins, then sample space will be Cartesian product of sample space of first coin 3 times. And we will get each element as order triplet. Similarly, if we throw one die, we get sample space 1, 2, 3, 4, 5, 6. And if we throw 2 dice at the same time, then we will get sample space Cartesian product of sample space for one die. And this will be ordered pair 1, 1, 1, 2, dot, 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 dot. Lastly, 6, 6. Means 36 number of elements in this sample space. Now we solve a problem. Problem is find the sample space for the experiment. A boy has 1 rupee coin, a 2 rupee coin and a 5 rupee coin in his pocket. He takes out 2 coins out of his pocket, one after the other. Now we have to find the sample space for this experiment. Solution. Let 1 rupee coin is denoted by O. Let 2 rupee coin is denoted by T. Let 5 rupee coin is denoted by F. Since boy takes out 2 coins, one after the other, if in the first chance he takes out 1 rupee coin, then in the second chance it may be 2 rupee coin or 5 rupee coin. So in the first chance 1 rupee coin, then second chance 2 rupee coin, in the first chance 1 rupee coin, in the second chance 5 rupee coin. If in the first chance he takes out 2 rupee coin, then in the second chance 1 rupee coin or 5 rupee coin. So we may write TOTF. If in the first chance he takes out 5 rupee coin, then in the second chance 1 rupee coin or in the second chance 2 rupee coin, and this will be the sample space. Now we solve problem number 2. Find the sample space for the experiment. A person noting down the number of accidents along a busy highway during a year. We have to find the sample space for this experiment. Solution. Since the person is noting the number of accidents during the year may be 0, means no accident, or maybe 1 or maybe 2 or maybe 3 or any positive integer. Therefore, sample space is 0, 1, 2, any positive integer. This is the sample space. Now we solve problem number 3. Find the sample space for the experiment. A coin is tossed. If it shows head, we draw a ball from a bag consisting of 3 blue and 4 white balls. If it shows tail, we throw a die. Firstly, coin is tossed. If coin is tossed, we may get outcomes head or tail. Here, coin is tossed, we get head or tail. If it shows head, we draw a ball from a bag consisting 3 blue and 4 white balls. Here we get head. Then we draw a ball from the bag. Bag contains three blue. This is blue 1, blue 2, blue 3 and 4 white balls. W1, W2, W3, W4. If it shows head, we draw a ball from a bag consisting 3 blue and 4 white balls. If head appears in the coin, then we have to take one ball from the bag, that may be blue 1 or blue 2 or blue 3 or white 1 or white 2 or white 3 or white 4 ball. If it shows tail, here tail, then we throw a die. Outcomes of die be 1 or 2 or 3 or 4 or 5 or 6. Here 1 or 2 or 3 or 4 or 5 or 6. So sample space will be, if coin is tossed, then if head appears, and then one ball from the bag, means head blue 1, head blue 2, head blue 3. In this way we get different outcomes. If tail appears, then die will be thrown. Then tail, then 1 from the die, tail 2 from the die. So sample space will be here head B1, blue ball 1, head B2, head B3, head W1, head W2, head W3, head W4. If tail, then tail and 1 from the die, tail 2 from the die, tail 3 from the die, tail 4 from the die, tail 5 from the die, tail 6 from the die. And this will be the sample space. Now we solve problem number 4. Find the sample space for the experiment. A coin is tossed. If outcome is head, a die is thrown. If die shows up an even number, the die is thrown again. we have to find the sample space for this experiment. Now we solve this. Firstly, a coin is tossed. If coin is tossed, we may get outcome head or tail. If outcome is head, then a die is thrown. If die shows up an even number, die may show even number or odd number. Here we write even number, even E, which contains number 2, 4, 6, or odd number O, which contains number 1, 3, 5. If a die shows up an even number, the die is thrown again. Then again we throw the die. Then die will give either 1, 2, 3, 4, 5, 6. Then we have to find the sample space. Here we get the sample space as here we get tail or head. Tail or head. If head, then it may be odd or even number for the die. So we get H1 odd number, H1, H3, H5. Then if a die gives even number, that means 2, 4 or 6. Let it gives 2. 2 is an even number, then die is again thrown, and we may get 1, 2, 3, 4, 5 or 6. Similarly, if a 4 appears, even number, then also 1, 2, 3, 4, 5, 6. And in this way, we will make the sample space. Now, H, then 2, and if 2 even number, then maybe 1, 2, 3, 4, 5 or 6. H2 1, H2 2, H2 3, H2 4, H2 5, H2 6. If here even number 4 appears, then H4 1, H4 2, H4 3, H4 4, H4 5, H4 6. If a even number 6 appears, then H6 1, H6 2, H6 3, H6 4, H6 5, H6 6, and this will be the sample space for this experiment. Find the sample space for the experiment. A coin is tossed repeatedly until a head comes up. If we toss a coin, we may get outcome head or tail. We have to stop our experiment when head appears. Let in the first time we get head, then we will stop this. Otherwise, if in the first time tail appears, we again toss the coin, and if it comes head, we will stop our experiment. Otherwise, if we get tail, then again we toss the coin, and if we get head, we will stop this. If we do not get head, then we continue our experiment. If tail, then again if we get head, we stop our experiment, and in this way we get T, and lastly if we get head, then we stop our experiment, and the sample space will be this. This is the sample space. Now we solve the next problem. Find the sample space for the experiment. The numbers 1, 2, 3, 4 are written separately on 4 slips of paper. The slips are put in a box and mixed thoroughly. A person draws 2 slips from the box, one after other, without replacement. We have to find the sample space for this experiment. Here in the box, 4 slips containing separately 1, 2, 3, 4. We have to take firstly 1 slip, and we take it outside without displacement, means we do not return back this slip. Then we take another slip from the box. Then we have to find the sample space. Let we take the slip containing 1 in the first chance. Then in the second chance it may be 2 or 3 or 4. If in the first chance we take 2, in the second chance it may be 1 or 3 or 4. In the first chance, if we get 3, in the second chance 1, 2 or 4, 1, 2 or 4. If in the first chance we get 4, then its second chance it may be 1 or 2 or 3, 1 or 2 or 3, and this is the sample space. Now we solve the next problem. Find the sample space for the experiment. Suppose 3 bulbs are selected at random from a lot. Each bulb is tested and classified as defective, symbol is D, or non-defective, symbol is N. Then we have to find the sample space of this experiment. Since we have to select 3 bulbs, the first bulb may be defective or may not be defective. The second bulb may be defective, may not be defective. The third bulb may be defective, may not be defective. So for this we make a table: first bulb, second bulb and third bulb. First bulb may be defective, may not be defective, that is non-defective. Second bulb may be defective, may not be defective. Third bulb may be defective, may not be defective. So we have to frame a sample space sample space S. Here first bulb may be defective, second bulb may be defective, third bulb may be defective. So we write DDD, that means 3 bulbs are defective. Then DDN, that means first 2 bulbs are defective, third is non-defective. Then DND, DND, then DNN, DNN. Now N, first bulb N, DD, NDD, NDN, NDN. Now NND, NND, then NNN. Since any outcome, let this outcome means first bulb is non-defective, second bulb is defective, third bulb is non-defective. So this is the sample space. Now we solve the next problem. Find the sample space for the experiment. A die is thrown repeatedly until 6 comes up. If we throw a die, then the outcomes be 1, 2, 3, 4 or 5 or 6. If in the first chance 6 appears, then we write 6. If in the first chance 1 appears and in the second chance 6 appears, we stop the experiment. If in the first chance 2 appears and in the second chance 6 appears, then we stop the experiment. And in this way, if in the first chance 5 appears, then in the second chance 6 appears, we stop the experiment. If it is not, then if in the first chance 1 appears and in the second chance 1 appears and in the third chance 6 appears, then we will stop the experiment. And in this way, in the first chance 1 appear, in the second chance 2 appear, in the third chance 6 appear, we will stop the experiment. And in this way, we make the sample space. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.